Hello viewers, good afternoon. This is Muhammad Abdul Halim and I am from my channel Flexomaster, and we are going to study today chapter number 21, which is corrugated board packaging. So we come to this chapter. Let's start. Corrugated board packaging, chapter number 21. Introduction. Corrugated fiber board is the most widely used secondary packaging material. It is typically constructed from two facings or liners bonded to a corrugated fluted medium. A corrugating machine forms the medium into a fluted pattern and bonds it to the liner using adhesive. Some basic configuration are shown in figure 1. In the left side, you have outside liner, then medium and inside liner. In the right side, you have medium, central liner, medium again, inside liner, because this is single wall, this is double wall. Single wall, one fluted medium with two liner plies is standard type for most product types. Double wall, two fluted medium plies and three liner plies used for heavier or more bulky products such as machinery, large appliances or furniture, or for display stands or for products which are stored for extended time periods. Triple wall. These three fluted medium plies and four liner plies used for particularly heavy duty application, example as a substitute for wooden containers for pallet boxes or bulk bins. A single faced material is also available made up of one fluted layer and one liner. This is a flexible material suitable for general purpose wrapping. Corrugated fiber board has been manufactured since the late 19th century with the first patents being filed in the United States in 1871. Much can be seen today that directly relates back to then, but the major shift in corrugator speeds for 1.8 meters per minute at 1.8 meters to that of 300 meters per minute at 2.5 meters wide is due to constant refinement and development. The first big step was the introduction of the Stein-Hall process in 1937, which used part of the starch adhesive mix bonding the papers to be gelatinized, whilst the remainder was carried as slurry, enabling a much higher proportion of solids to be used, 21 to 23% starch suspended in water. Drying time was reduced, allowing corrugators to run at higher speed and produce board with minimal warping. Although this process has in the main changed back to a single bag mix, the starch is modified to enable this carrier and slurry action to take place. It is this type of chemical development combined with automatic reel splicing, direct drive, shearing knives, precise computer-driven gap, and temperature control that enabled this increased in manufacturing speed. The materials of corrugated board, there are three basic components required: liner or facing materials, flute materials, adhesive. Liner and facing materials can be made from craft paper named after chemical pulping process used to manufacture the paper, which has a high proportion of virgin fibers and added recycled papers known as test materials. The recycled papers are made from in process waste and from used cases and trays collected from supermarkets and other outlets. These test materials owe their name to be obsolete puncture test demanded for railways distribution and are categorized as TL1, TL2 and TL3. The long fibers on the outer ply of TL1 and the highest performance amongst all test materials mean that it is used as a craft substitute, whereas TL2 and TL3 are only distinguished by their short span compression strength values and are mostly widely used papers. TL3 is the most common, with the higher performing TL2 being used in more challenging environments such as frozen food packaging. Varying amounts of recycled or secondary fiber are used for producing both liners and corrugating medium, a practice which has grown as recycling has increased. Recycled board is made to the same specification as virgin material, so that stiffness and burst values are similar. Although it is slightly thicker to compensate for the weaker recycled fiber, other properties will depend on the source and quality of the fiber. Recycled board typically has a somewhat smoother surface finish and therefore better printability and a lower coefficient of friction than virgin craft. Recycled board may absorb water significantly faster than craft, which could be important when packing wet products as a fish, such as fish. Whether test or craft, white or brown, corrugated materials can be found performing quite satisfactorily on the wide range of tray, wrap round and case erecting and packing machine in use. By using bleached fiber combined with craft, a whiter surface providing better graphic presentation can be obtained if the bleached fiber layer is thin and not uniform. Some of the background crafts shows through giving it is a mottled appearance. Mottled white and austere board are common commercially name used to describe this board. Papers with thick, even layer of bleached fibers have in the main replaced fully bleached white craft. The two-ply natural and white craft material is used where high quality graphics are required and it is sometimes enhanced with a clay coated finish. It is typically used in preprint applications, whereas the outer layer of material is printed before being made up in corrugated board. This avoids the lined effect obtained when printing on a corrugated surface. A balanced construction is one where the outer and inner liners have identically weights or grammages. However, corrugated board can be manufactured using liners of different types and grammages, using a heavier liner to ensure a better outer surface for printing. Unbalanced construction tend to have more problems with board wrapping, but can be appropriate on the grounds of cost and or functionality. For better printing, the heavier liner should be the outer liner, whereas for better compression strength, the heavier liner should be on the inside. Now, fluting materials. Fluting materials, one ply uh, sheet produced from recycled and or virgin fibers. Where virgin fibers are used, the pulp is prepared using the CTMP pulping process in other chapter, given a short fiber suitable for corrugated. This is known as chemical fluting and currently represent only a small percentage of fluting used. The majority being made for chemically enhanced recycled fiber. This is range of standard flute size in table 1. A is the flute, the largest size, 105 meter to 125. Approximate height of flute is 4.5 to 4.7. The C flute, the second largest, 120 to 125 flutes per meter, and height of the flutes is 3.5 to 3.7 millimeter. B flute, the third largest, 150 to 185 flutes per meter, and 2.1 to 2.9 height of the flutes in millimeter. E flute, the fourth largest, 290 to 320 flutes per meter, 1.1 to 1.2 flutes height in millimeter. The F and the other flute sizes are 400 to 440, 0.7 to 0.8 height of the flutes in millimeter. Table 2. Now summarize the differences among the main types of flutes. A flute is useful for cushion pads, the construction of particularly heavy duty boxes, and construction of triple wall board grades where the added thickness is an advantage. However, use of A flute has been in decline. A flute's almost 5 millimeter thickness occupies more space than C flute and has significantly greater deflection before bearing load and when compressed. Here is the details. Flute height for A flute, flute per meter, F, stacking strength best, puncture good, cushion best, poor, flat crush poor, surface print quality poor. And in 3.5 to 3.7 C flute, you have flute per meter, good, best, cushion is good quality, fair, flat crush, flat, and fair. Now in B flute, you have 154 fair, puncture resistance fair, cushion fair, flat crush good, surface print quality good. Similarly, for E flute, F flute, N flute, and G flute. And this material, in theory, a flute's thicker section should give the highest top to bottom compression strength of three flutes. This is true under laboratory conditions. However, A flute has the lowest flat crush resistance. See in the table 3. And this makes A flute with less than 127 grams medium almost impossible to machine and transport without destroying the flute structure. Engineering studies suggest that A flute is most efficient when constructed with a 200 gram medium. Medium grammage is 127 gram, A flute 0.7, B flute 1, C and 1.5, 140 gram medium grammage, 0.9, 1.25, 1.45, 200 gram, 1.1, 1.5, and for C flute it is not applicable. And these are the relative flute flat crush values. C flute has about 10% better stacking strength than the same board weight in B flute. It is best for application when the corrugated container must bear some or all the stacking load. C flute is sometimes chosen over B flute for cases that withhold glass bottles despite C flute's lower flat crush strength. It is felt that the thicker flute will provide more puncture protection for the glass. Some authorities regard lightweight medium C flute as having less than minimum acceptable flat crush for shipping application. B flute is used for canned goods, other products where case stacking strength is not required. B flute high flat crush strength is an advantage when supporting heavy goods such as bottles or cans. It can also be used to advantage for lighter load application where high stack strength is not needed or where the distribution environment is very short. Heavy media cannot be made into the small B flute. A recent development offering material and space saving over B flute is R flute corrugated board. The flutes are smaller and closer together than B flute, resulting is better printing surface and 20% lower caliper, meaning more board can be shipped per pallet. C flute has about 10% better stacking strength than the same board weight is B flute. It is best for application where the corrugated container must bear some or all the stacking load. C flute is sometimes chosen over B flute for cases that withhold glass bottle despite C flute's lower flat crush strength. And it is felt that the thicker flute will be provided more puncture protection for the glass. Some authorities regard lightweight medium C flute as having less minimum acceptable flat crush for shipping application. And E flute and smaller flutes, often known as micro flutes, are not generally associated with shipping containers. They are mostly used to replace carton board for heavier or especially protective primary packs. E flute is an excellent choice where the primary containers may become an RRP container for some part of its uses. There is a range of finer flutes such as F, G, N, and T. Some specific to certain manufacturer and used when high quality graphics are required. Gift packs for drinks, etc., is a typical end use, as well as cases from small tools, hardware appliances, and homewares. Flute materials, again we continue the slide. Is double walled or triple walled constructions can have a combination of flute types, perhaps E and B on the outer, B and or C flute on the inner, offering a flat surface for printing combined with load-bearing flute on the liner. Triple wall materials are often the exception to their and have load-bearing C or A flutes throughout to provide the strength needed for industrial applications such as heavy engine components. Liners and corrugating medium material can be made to virtually any weight or thickness. However, custom and practice has led to the standardization of a certain traditional grades. See in the table 11.4 is coming again in the next slide. Finished board is described by component grammage. The mass is grams per square meter. Measurement start from the outside. Corrugated board described as 170, 127 C, 170 would have the following component. Outer liner is equal to 170 gram, medium 127 gram formed to a C flute. Inside liner 170 gram. And corrugated board specifications sometimes disregard the facts that paper is naturally product. A given paper board characteristics can easily vary by 8% or more by tolerance levels must take into account. Adhesive selection. A standard corrugated board is made with a starch-based adhesive applied at about 10 to 14 GSM. Starch loses strength at high moisture levels. However, corrugated board also loses around 50% of its compressional strength between 50 and 90% RH. So both need relative humidity 90%. So both need some of form of reinforcement or protection in wet conditions. Where high resistance is needed, starches can be modified by adding various polymers. Water-resistant adhesives are more expensive and are typically used in conjunction with corrugated board that has liners with a membrane or coating to repel water. Cold adhesives such as polyvinyl acetate (PVA) are normally used to glue several corrugated sheets to form extremely strong materials for heavy-duty application. So, here we complete the chapter number 21 and we will go ahead for chapter number 22. So we completed here the chapter number 21 corrugated board packaging and we will continue for the same subject corrugated board packaging in our next video of chapter number 22. And thank you very much for watching and kindly subscribe, comment and share this channel for those who needed the full information on printing and packaging. Thank you and see you.